Welcome to the Explainer. This is where we break down really big ideas, all with the power of slides.
All right, let's just dive right in. Imagine this. Fourth down, the game is on the line. This is one of the most high-pressure decisions in all of sports, right? The clock's ticking down, the crowd is just roaring, and the coach? Well, the coach has to make a call that could literally win or lose the whole thing.
And for decades, decades, this decision was all about one thing: the coach's gut. You know, that mix of intuition, experience, feeling the momentum of the game. But today, well, there's a new player on the field. And this one doesn't wear a helmet. We're talking about data, the computer's code, and it is absolutely changing how this game is played.
So that's the big question, isn't it? Can we actually build a model to make the perfect call? Well, today we're going to try. We're cracking open the book statistics every programmer needs to see how a statistical model can tackle this exact problem. And we're not just talking theory here. We're using real data, play-by-play, from the 2023 NFL season.
Okay, so where do we even begin? Well, the first step is always to get your hands dirty with the data. We've got to sift through literally thousands of plays to find the patterns, the things that matter. You'll hear data scientists call these features. Basically, we're hunting for the clues that might predict whether a team is going to make it on fourth down.
So what kind of clues are we looking for? Well, a whole bunch of them. We're looking at things like what quarter is it? What's the score difference? And of course, the big one, how many yards do they need to get that first down? That's TO go. Then there's the play call itself. Was it a run or a pass? And even where the game is being played. Are they the home team or away? All right, first up, score difference. And yeah, it seems to play a role. You can see here that teams that go for it, whether they make it or not, tend to be trailing. The median score difference is negative for both. But look at how much those bars overlap. It's a clue, for sure, but it's not the whole story. Not by a long shot. Okay, now hold on. Look at this. This is where things get really interesting. The yards to go. The difference here is just, wow, it's dramatic. When a team succeeds, they usually need fewer than 3 yards. When they fail, more than 5. See that gap? The data is practically screaming at us. This is the single most important factor. It's huge. So we found our most important clue. But how does a computer take this insight and turn it into an actual strategy? It can't just look at one thing, right? It needs to weigh everything together. And that's where a really cool model called a decision tree comes in. What's a decision tree? Honestly, the best way to think about it is like a super smart game of 20 questions, but for data. It's basically a flowchart. It asks a series of simple if-then or yes-no questions to split the data into smaller and smaller piles, trying to get to a point where one pile is mostly successes and another is mostly failures.
And this is the brilliant part. The model could have started by asking anything. It could have asked about the score, the quarter, home field advantage, anything. But it crunched the numbers and figured out the single most powerful first question to ask is this one. Are the yards to go, the TOG underscore, less than or equal to 2.5? That one question, right off the bat, gives it the cleanest split in the data.
But that's just the first question, right? It's the trunk of the tree. From there, it branches out into a full-blown strategy. Let's actually follow one of these paths through the flowchart to see exactly how it makes a final call. Okay, so let's follow along. Step 1. Is it 2.5 yards or less? Let's say our team needs 2 yards. So that's a yes. Cool. Now the tree asks the next question. Is the score difference less than or equal to negative 11.5? That's basically asking, are you losing by 2 scores or more? Let's say we're only down by a touchdown, so negative 7. That's not less than negative 11.5, so the answer here is no. Okay, one more question. Was the play a pass? Yep, they decided to pass, so we get a yes. And just like that, by following that simple path, yes, no, yes, the tree lands on its final prediction, successful conversion. So the big question, how good is this thing? How well does our digital coach actually do? Well, when we test it on plays it's never seen before, the decision tree gets the outcome right 61% of the time. Now, that's definitely better than just flipping a coin, but there's a really interesting wrinkle in that number. Because when you dig into that 61%, you find this fascinating split. Look at this. The model is actually pretty good at predicting when a team is going to succeed. It gets that right 72% of the time. But when it tries to predict a failure, the accuracy plummets to 51%. That's basically a coin flip. It's a huge tell. It means our model has a much better grasp on the recipe for success than it does on the ingredients of failure.
So, to get around that weakness, analysts usually don't stop with just one tree. They bring in a more powerful technique called a random forest. And the name is pretty descriptive. Instead of trusting one expert, you build a whole committee, a whole forest of slightly different decision trees. Then you let them all vote on the outcome. It's like getting a second, third, and 100th opinion, which makes the final call way more robust. So, did the big committee of experts blow the single tree out of the water? Well, no. The accuracy only went up to 62%, just a 1% bump. And that's actually super insightful. It tells us that all that extra complexity didn't add much. The real predictive power, the secret sauce, was already there in that simple single tree. And it all comes back to that one killer question: how many yards to go?
And this is where we zoom out, because this is the real takeaway. This whole thing isn't just about football, not at all. It's about a way of thinking. It's about taking a huge, messy, complex problem and breaking it down into a series of simple, answerable, data-driven questions. I mean, this exact same logic using decision trees is an absolute workhorse in tons of other high-stakes fields. You'll find it in finance, trying to predict stock prices or sniff out fraud. You'll see it in business, forecasting when a customer might be about to leave. It's even a tool used in medicine to help make more accurate diagnoses. It's everywhere. And that's the whole point, really. As the book's author says, the goal isn't just about numbers on a screen. It's about transforming data into decisions with confidence. Taking all that abstract information and trying it into something real, something actionable. So let's bring it all home. What's the big takeaway here? It's that whether you're on the 50-yard line or in a boardroom meeting, using data isn't about replacing your gut. It's about making your gut smarter. So the next time you're facing one of those tough, high-stakes choices, stop for a second and just ask yourself, what is the single most important question I should be asking right now? Find that question, and you're halfway to the answer. Thanks for watching.